Today we will start this session now. This is the third day. First session is handled by Principal Dr. Manoj Khanna, Principal Scientist and in charge Farm Operation Service Unit, Water Technology Center, Indian Agriculture Research Institute, New Delhi. So he acquired his PhD in Civil and Environmental Engineering from University of Melbourne, Australia in 2001. And he did his MTech from Indian Institute of Technology, Delhi, and post diploma in Business Administration, Board of Technical Education, Delhi. And he did his undergraduation in Agricultural Engineering in Sukhantia University, Udaipur. And his employment history, he is working as a principal scientist, IARI, Indian Agriculture Research Institute, since January 2009. And his contribution to the scientific advancement, he developed a two-dimensional simulation model, design and operational guidelines for basin border irrigation layouts. Then he performed a design, operation, and management schedules of micro irrigation and fertigation system for various vegetable crops. He contributed towards water and nutrient transport modeling in micro irrigation fertigation. He developed strategies to enhance adaptive capacity to climate change in vulnerable regions of Mewat and Dhar districts through integrated water saving technologies. He developed an aggregate drought index for drought monitoring and validated for Indo-Gangetic Plains and Maharashtra state. And his current area of research and project includes climate change modeling and adaptation, impact of climate change on water resource availability in river basins, precision agriculture and irrigation management, drought indices and monitoring system. Another area is precision agriculture for enhanced input use efficiency. He's the principal investigator for that project. Then another project is regional water resource management for sustainable agriculture and food security under changing climate. Then he leads the project National Initiative on Climate Resilient Agriculture. Then another project, North Indian Center for Water Technology Research in Agriculture. He has got 77 journal publication, 5 book chapters, and other proceedings, training manuals, etc. So he got awards, NBCC Prize of Excellence, for being academically best student of civil engineering department in IIT Delhi during his MTech in 1992. Then MA SHAV Fellowship of the State of Israel in 1994, Melbourne International Research Scholarship that during the period 1997 to 2001, that is for doing his PhD. Melbourne Research University of Melbourne, Australia, Best Research Paper Award in 2010 and in 2007 also. So here today, Dr. Manoj Khanna, very eminent personality, highly distinguished academician is with us, and he leads a lot of projects. So our IoT framework development for agriculture sector, he is a very right person to talk on that. So on behalf of all the participants and from the management and staff of LBS College of Engineering, Kasaragod, we extend a warm welcome to Dr. Manoj Khanna. Welcome, sir.
Thank you. Thank you.
Okay, I thanking him for accepting our invitation. I had contacted him over telephone. I got his contact through one of the colleague working in the agriculture area. So he readily accepted. So I on behalf of college, we thank you, sir, and on behalf of the participant, session is handed over to you, sir.
Thank you, Dr. Mary, for your kind words, and good morning to all participants. And as mentioned, Dr. Manoj, I am Dr. Manoj Khanna, working in this water management, agriculture water management, on-farm water management for the last 35, 36 years. And here I've been assigned a topic on application of IoTs for precision agriculture. So can I share my presentation?
Yes, sir. Please share. Okay.
Is it visible to everybody or not?
Yes, sir. It's visible.
So I can start right away.
Yes.
And this topic assigned to me is IoT-based precision agriculture. And Dr. Mary has already introduced me. And I thank you. I thank college also, Dr. Mary also. She contacted me long back, in fact, during the COVID period. And I thought it will be a good opportunity for me to talk. And I was not sure at that time what will be the scenario now. And you people are in your state, you are facing a lot of problems in the area of COVID. I appreciate, and it's really appreciate that so many people have joined in this lecture. Thank you for taking your time out, and we will start right away. Let me just give me the outline of my talk, what I will talk about, and initially I will talk about about the IoTs and precision agriculture, what we are talking here, and why we need precision agriculture, and all these things, and then linking it with the IoTs, and then I will talk about somewhat early development of precision agriculture. This is not a currently, you can say it's not a new topic, but for the last 10, 15 years, people are talking about precision agriculture, and a lot of development took place in this area with respect to electronics. Please remember this thing that I am an agricultural scientist, agriculture engineering come civil engineer, and my expertise is not electronics. So I always look forward for the people who are expert in that area, and where my expertise in water management or agriculture area can be combined together to come out with kind of applications. So we will be talking about a lot of applications during the lecture. Some of the research initiatives we have been working on this area. I've been leading this project from 2009, a project initiated at the national level, institute level, a flagship project we call it, and cutting across all disciplines. And it is a combined big project with a team members of something like 40, 45 scientists. And a team was created, and to start working on the precision agriculture, different application, different aspects of agriculture, where your application of precision, as well as combining together with IoT or latest technology, data, big data analytics, and artificial intelligence, which is now the buzzwords everywhere. You will hear about it. Even our Prime Minister normally talks about it. So I will be talking somewhat some of those details and touching those topics on that, because this is a vast topic. We cannot combine it together probably in a 1.5 hour lecture. So I will be touching these aspects. Many of the things about the technical, about the electronics part, you will be the more knowledgeable than me, probably. But at the same time, what could be the application? So where our agricultural knowledge or our team's agricultural knowledge is combining together with the electronics people and coming up with the simple low-cost applications of IoTs for our precision agriculture. Then we will talk about applications of IoT for precision agriculture. We are working together with the startups also in our institute, and those people are really helping us to convert those concepts or our ideas into more like applications and a product, and which could be directly adopted by farmers and all that, and then followed by some concluding remarks. So let's start with that. And I start with a start with a basic topic, IoT-based precision agriculture. And if you look at the being a water scientist, I always have a feeling of water with us. And remember this thing that without water, nothing, no agriculture was possible. So look at the agriculture. For the last 2 years, everyone has a feeling that during the COVID period, everything stopped, but not the agriculture. And this agriculture support is only helped us in overcoming this whole COVID or our food security and all that. So remember, this our total farm output, which is coming totally almost 60-65% is totally dependent on monsoon. And we are not lucky like Europe and all that, where 12 months rain is happening and good distribution is happening. But we are more of a, every year we look forward for the monsoon, what is happening to monsoon, how the water is coming and all that. And remember, our major water use is, we have almost 2.5% of land and 4% of total water allocation on the world. But major user of that water or fresh water is almost 80-85% is going towards irrigation. And then comes the industry and domestic and other things. And remember, our population is keep on rising. We are talking about 16-17% of world population with a very, very limited resource. And there the lot of emphasis is that if water is not there, what will be happening to our country? So another aspect of a very critical aspect is 60% of water used in irrigation is somewhat wasted. We call it wasted or efficiency. We are talking of general water use efficiency, or the irrigation efficiency is in a major area is 30-35% or to the mean. Can reach to something like 40%. So we have to work on these kind of aspects and how best, and with the limitation of labor and all those things with the technology, how this simple technology can be applied in our agriculture sector for the benefits of our farmers. And earlier we used to have most of the engineering colleges, those who are working for computer science and all that and engineering, are not really bothered about rural area, but the concept is slowly changing. Now there is a need to have a joint effort between the agriculture people and the electronics people, or the people who are from the engineering side, combine together and come out with these simple and low-cost solutions for our farmers, and ultimately benefiting our agriculture, water sector, every sector. I think so it is linked with water or agriculture sector, and ultimately our overall growth of the country. Now here I am just talking about precision agriculture. It can be simple as a definition, and its application of modern information technologies to provide, process, analyze multi-source data of high spatial and temporal resolution for decision making and operations in the management of crop production. Remember, there are a lot of keywords are here, like you are talking of process, the multi-source data. That means we are talking of a large amount of data, both in a spatial scale as well as temporal scale. And ultimately decision making are our decision making. If you talk of a last mile connection or a farmer, he is the decision maker. So we need to give up the solutions which he can make decisions or very quick decisions, or simple information is provided to him, and then he can make his operation and management in crop production. That's how we are looking for IoT in agriculture or in a precision agriculture. Why precision agriculture? Let's talk about the ultimate goal is to provide productivity in agriculture. Remember, our productivity is still, we are producing almost 310 million tons of food grain. Our granaries are full, and a lot of food is available with us. We are exporting a lot of amount of grains, vegetable, fruits, and all that. But at the same time, our productivity, if you look at the contemporary countries, China or America, where is basically still very low. if you look at the average productivity, but at the same time, we have productivity, very high productivity in sectoral area, talk of basmati rice or talk of some kind of wheat production in some areas, but average productivity is still low. And remember, our productivity can be increased by through genetic potential, like breeding of new varieties and all that. But at the same time, that potential is more or less we are reaching towards that direction. But now the more of a agronomy and management aspect where our production or productivity could be increased. Resources are limited, be it water, land, labor, all those things are there. So our one of the key point is the soil degradation of a cultivable land. We are getting more and more production and all that using high-tech values or products and all that. A lot of chemicals have been provided to the land. So leading to a lot of soil degradation in cultivable land. So we wanted to protect and ultimately our best efficient or uses of natural resources, be it water, fertilizers or chemicals in a controlled manner, then only our soil degradation could be stopped. We don't want, a lot of buzzword is there. Just few days back, there is a news item that our vegetables have been rejected in European market or some export market because of the excessive use of pesticides, chemical in crop production. So we wanted to cut down those things and through various technologies, I will talk of phenomics also, little bit of that and application of pesticides or chemicals or pesticide use in our crop production system. How can we stop that? One of my key area or my love is efficient use of water resources, which is I always worked on for the last 30-35 years and efficient use of where there is kind of application of precision agriculture, IoT, we will talk about in detail. And then comes the farm management. We are still bothered about very, very small land holdings, but at the same time, we have a large production systems, be it seed production companies, national seed corporations, which have a almost average size of a farm is 500 hectares. So we are looking for efficient farm management. And remember, I've been working as in charge of farm operation service unit, which is looking after almost 250 hectare area of production system in IARI, Indian Agriculture Research System. So that is another area where I am trying to implement some of the technology which are available for efficient farm management. Then lastly is a dissemination of modern farm practices to improve quality, quantity, and reduce cost of production. So ultimately, we are looking for some, remember, we have a kind of a penetration of mobile phones and all those things in our country. And all those people, even illiterate people, is working with the mobile apps and running it, developing TikTok videos where no teaching is required to him. And he is trained himself. And why not our simple apps in mobile-based apps can be trained to the farmers and they can use it. And where we did some project with the Tata Consultancy Services in a PPP mode. And I will share you some of the results or some of the technologies which we did and how we use of our information technology or IoTs or information gathering and dissemination could be helpful for them. Now, let's talk about early development of precision agriculture. Here, I will show you some of the applications, what happened in last 10, 15 years or 20 years, I can say. Where some of them in which I am being involved or some of them I have taken from literature. Now, most commonly, GIS and remote sensing based technology in agriculture production system is very, very common. Last 25, 30 years, it has been happening. And both GIS as well as remote sensing based information, our remote sensing ISRO is one of the leading light in our country and providing lot of remote sensed information and using that information for weather prediction or farm production system or a yield prediction is being done. And on the basis of that, we have come up with a spatial decision support systems for both water and nutrient application. And another is a livestock application. So when we talk of precision agriculture or agriculture systems, we are talking of agriculture crop-based system as well as livestock-based system, dairy production system. So there also a lot of applications are needed or for enhancing their productivity, and there lot of applications have been used, and some of them I will share you, and how the things are moving in that direction. We will talk about that. Some wired and wireless automation in micro irrigation system. So I've been working with micro irrigations, I think so since 1985, 86. And a lot of automation is happening in micro irrigation, and both in a surface covered cultivation. So where I talk of surface covered cultivation means we are talking of greenhouse cultivation and all that, or for high value crops. Their automation is there. And initially it was more of a wired automation, and slowly with the advent of new technologies or wireless communication technologies, which has been developed probably in the last 15 years or 20 years. And a lot of now moving towards the wireless automation of micro irrigation systems. I will share some of the actuator based operational automation in supply and demand management of on-farm water management. Here I was involved I did my PhD from Australia, so I got an advantage, and I worked with the university and worked with a big project on a dairy irrigation automation, and they are commercial actuator based. We will talk in detail. Those kind of things have been happened in a supply and demand management of on-farm water management. A lot of water emphasis linked with the soil moisture systems, with a dairy production system, with kind of a softwares or apps linked with the irrigation hydraulics, and come up with a production system. And where dairy is a big industry, and where the whole income of dairy farmers are based on the grazing, how frequent grazing is required, or how much grass to allow to grow, how much amount of irrigation is required, and where the water is being charged to the tune of something like $30 to $40 per megaliter, and where farmers are paying that kind of amount for buying water for irrigation. So every economics of the whole system is very, very important for automation. And there the kind of automation has been happened, and it is being commercially happening, which I will be sharing with you. Now let's talk about global scenario. What has happened in global scenario for irrigation automation or automation of precision agriculture, in terms of a linking it with respect to some IoTs. IoTs are more like a latest phenomena for the last 5-10 years, but automation is happening, like irrigation schedule based on some canopy temperature and soil moisture in orchards and all, with the crop production system. Some microcontroller based systems like crop temperature or a water stress and status. And these kind of systems are very commonly used in a micro irrigation. Some low cost tensiometer. Tensiometer is a device which monitors the soil moisture, and its device is not new, I can say, and this is happening for the last 40-50 years. Tensiometers have been, they are all manual based, trying to convert them in some kind of a digital information, and then trying to convert it into more like a automation. Wireless infrared sensor based on the temperature based canopy temperature, those kind of thing. Then microcontroller, as I told you, they are simple on-off type of devices. You fix up a time and they turn off or turn on with respect to time. We have already done that. Where the labor is scarce, and you are talking of 100 hectare, 500 hectare area of a irrigation system where the already controller system is there, and you just simply turn on, where assured water supply is there. And we are not talking of shifting of supply or like assured water. The water is always been available. Those kind of systems have been very common in the international scenario. Digital control systems using onboard computer to implement radio-based transmitted instructions, installation of both sprays, low energy precision application of water, or sprayers or pesticides. Another most common phenomena is a moving irrigation machines with a computer control for differential irrigation. Now this kind of center pivot irrigation application is now being used in our national seed corporations, big seed farms of the size of something like 500 to 1,000 hectare, this center pivot. And these machines are, they cannot be manually controlled. So they have a controller system. You fix up a control and that how many revolutions per 24 hours and so on like that. And we have wanted to apply differential irrigation in a part of the area. You want to have some kind of crop which does not require excessive water, or the water requirement is different. So linking it with the kind of thing. Variable fertilizer applicators is another area which is the international scenario is one, because whatever idea is in a precision agriculture, whatever is the soil demand, crop demand, you trying to match that demand perfectly to the in a precise manner. So is it possible that in a large area of 100 hectare area, you have a variable fertilizer demand of a patches or a grids, and you apply based on their requirement, and then you apply it. Again, in a crop also, as the crop grows, the demand varies for nutrient. And as the crop grows slowly, there is a demand is something like the highest, and when it's a reproductive system is active, and there the fertilizer demand is there. So you want to apply that kind of fertilizer or application based on their whatever is the demand or crop demand or soil demand. All these things, if you are able to match it, this is what precision agriculture is. You wanted to avoid the increase the nutrient use efficiency, fertilizer use efficiency, or application efficiency, which is currently is 40 to 50% or 30 to 40%. Can we make it to 80 to 90%? Then only it is you can talk of better precision or application. Then comes the application of green energy. Solar is happening in all over world, not only in India, but long back it is happening in all over the world. So which is now happening in solar energy application in agriculture. Some kind of a semi-automatic or automatic gates for water sensor feedback control system in a surface irrigation, which is again an area where I have been working for quite a long time, and I will be sharing this kind of information, which is being practiced as I gave you the actuator-based information in Australia for dairy irrigation, and it is commercially available and farmers are adopting it for their application of water. So this is somewhat I cannot say this is an exhaustive list. This is some of the list which I feel are very important, where our role of electronics engineer or people expert in electronics and combining together with agriculture people or engineering people, then coming out of the solution where their ready market is available, our large farming population is available for taking up this kind of technology. Besides being application in a research or areas where the people are still working for crop improvement or like economics monitoring and all. Now let's talk of a rationale why we are going for that. What we are looking for: estimating optimum sowing density, irrigation water, fertilizer, herbicide, insecticide, fungicide requirement and schedule through appropriate low-cost sensor technology. So idea is to first sense the information, sense the requirement, and apply accordingly with the machine management, or collect the lot of information and then accordingly use your knowledge systems or heuristics, and then coming out with the solution, and then machine will apply and directing machine to do that kind of thing so that your efficiency could be improved. Efficient application devices, obviously once you sense the information of all these demand, be it for water, fertilizer or pest, and then schedule it with respect to sensing, and then you need to develop a application devices for precisely applying these inputs as per the need, both crop need, both spatially as well as on a temporal scale. So our challenge is big. We are talking of a spatial distribution also as well as temporal distribution. So because crops or agriculture production system or crop production system is basically both spatial variability is always there and a temporal variability is there, because temporal demand is varying with the biological demand of crop production system. Then comes the standardization and application of some novel products for resource use efficiency. Some products have been developed which we wanted to apply to enhance our water efficiency and all that. Then an idea is to come up with a decision support systems or tools, apps, and mobile-based apps, and so that the dissemination or the application could become much more simpler and everyone can do it by hand. So our aim, what our goal is, are focused on helping farmers close to the supply-demand gap by ensuring high yields, profitability, protection of the environment. These are our general goal, and using IoT to ensure optimum application of resources, high crop yield, reduce operational cost, and ultimately linking IoT with precision agriculture. So if I say 3 Ps is precision, profitability, prudence, and demand coherence, management through precise use of inputs for sustained agriculture production system. This is our ultimate goal, is 3 Ps, precision, profitability, prudence, and you can keep on adding it, anything in that, and ultimately what we want, this kind of a system. Before I move forward, I know you people know much more better than me on IoT. IoT is Internet of Things. It's a network of physical object things embedded with electronics, software, sensors, network connectivity. And these type of words are very, very common to you. Maybe for us, it is something big. We talk of sensors, software, electronics. For you, it's a bad day-to-day working sort of thing, because being an electronics engineer, so you people, network connectivity. Now these things, why these things are very, very important? Because now things are becoming much more simpler. Availability of internet, availability. Remember, this kind of technology, we are talking of probably 2,000, 2,500 kilometers away from each other, and we are talking to each other and giving the discussion and doing all kind of things. Some of the applications, they are not exhaustive. Again, let me say you some of them which I've been associated with, or some working on, or where I come across in my institution or in my project, all these things. So crop water management, it's one of the top management. Then pest management and control works, and where the precision is very, very important. Precise detection and application of nutrients. So there the cost is involved. We want to cut down the input cost to enhance the income of the farmers. We talk of doubling the farmers' income and so on like that, where these kind of technologies have a very important role to play. Food production and safety, because of spray and all those things, and we wanted to talk about that. And storage monitoring, this is another area where we are talking of, because we are storing almost 50 million tons or 70 million tons of food storage in our godowns to have some kind of a buffer storage and all those things for our rainy days. So those kind of applications are very, very important in agriculture. If I am going a bit fast or slow, please tell me, and because that's a limitation of these kind of technology or Zoom and all that, where we don't get the reaction from the audience.
Sir, it is in right pace, sir. No comments in chat box.
Okay, thank you. Because I'm not able to see those kind of things because I'm facing the only presentation. Now let's talk of start with the water again, because my area. And what we are talking is a normal efficiency, as I told you, is almost 30 to 40% only. And which can, there are two types of systems when we apply water. It's a surface irrigation or a modern irrigation, be it a sprinkler or trickle irrigation or drip irrigation or centrifuge. There the efficiency we are talking of, we can achieve efficiency to the 80 to 90%. Please try to keep in mind the kind of efficiency with where in majority of places we are working on is only 30 to 40%. So just see, if we are able to increase our efficiency by say 20% or 50 to 60%, forget about attainable efficiency, how much water we are able to save and how much additional area of irrigation we can brought into our production system. Remember, our crop production is coming from 75% crop production comes from an irrigated area, and rest goes from a rain-fed area. So if we are able to increase our irrigation efficiency or saving water, how much additional area we can bring in and how much productivity we can reach it. Currently, we are talking of 310, 15 million tons. Our need probably by 2050 is 400 million ton or 450 million ton based on our population and all. So we have to keep on working on these kind of things. Then only we will be able to achieve our food security, because that's the most important in our any country's issue. Now I will show you some of the irrigation applications of early applications of modern applications. Like in a manual operation of a irrigation, when we apply water, our fundamental says that you cut off the supply after water reaches to something like 2/3 distance of a basin. And if that is cut off, and then you the efficiency is you can achieve it to 70–80% efficiency. But this is all manual operation. Farmers does it, and he allow waters to reach it to at that stage and cut it the supply, and then efficiency is better. Now, what are the disadvantage? It's more of a labor intensive. You need to have been there in time. Cost is there. A person has to be there, and a lot of hassles are there. Our farming system is also changing. Remember, our younger generation, who is more of a mobile generation, it doesn't want to work in the field. So nobody wants to spend his time into the field in the midnight when the power comes and you apply water and wait for the water to reach a particular stage and then cut off the supply and shift the water to another basin or border. And it creates a lot of his lifestyle problems. So those kind of things has to be avoided. So those simple solutions, if you are able to develop those kind of things, and many times it happens that he doesn't bother about cutting down the supply and leading to a lot of waterlogging, and then leads to structural degradation of soil, greenhouse gases, loss of productivity, lot of pest and disease and increased cost. Then you are applying excess water, which is waste, cost. Lot of leaching happens when you apply nutrient. The water along with nutrient leads to the groundwater. It increases the groundwater table, lot of salinization, you loss of nutrients and in the form of nitrate, leading to the pollution of groundwaters and causing, and when you apply pesticide along with water, they goes down, your contamination happens. And then some overflow happens, nutrient and sediment loss happens, erosion happens, stream pollution when the water goes into our streams, groundwater table rise, salinization, pesticide, cost of recycling if you want to recycle that poor quality water, and then loss of productivity. So basically what we are doing when we are applying excess water, which is very, very common in our country, leads to problems and leading to low productivity, loss of water, pollution, all those things. So what could be the best solution of it? And our farmer doesn't know when to irrigate, and he knows only by his own experience. His life goes into farming, so he knows when to irrigate. And when you are applying when to irrigate based on time, you have a controller, you apply water based on time, could lead to the lower application efficiency. And as a quantification, if you know, he doesn't know how much water he is applying, whether he is applying need base, if it is a 5 centimeter depth is required, whether he is applying 10 centimeter, 15 centimeter, or 2 centimeter. So he doesn't know, because he has no system of monitoring those kind of things. So he doesn't know all what is happening, excess water, where it is going, why he is wasting this water. So those kind of critical gaps are there where you need a kind of a technology and applications to that. So what can we do? You need a new technology for efficient irrigation and scheduling, most efficient and cost-effective way of how to right amount of water, that means how much, and right time when to irrigate. And then ultimately this whole package need to be transmitted to the farmers, that only gives the solution to overall water management or efficient water management. Again, in our context, it has to be low cost. It has to be simple. It has to be in a regional language. All these things are to be added features or cherry to our solution. Then only this technology can be solution. Now, one solution out of the box is most commonly now is being talked is the automation. And we have a options of a wired, both sensor based or sensor without sensor, as well as wireless. Wired, both sensor based and sensorless, and wireless. So we talk of wired is becoming more and more obsolete now because of the betterment of the technology, communication, be it RFID or GSM based technology or a low cost Zigbee or LoRa. We'll talk about it, some of them in our further discussion. And those kind of options are available for giving the solution. Now, let's take off, we were talking of irrigation automation. So our basic premises is once the water reaches to at a distance of 2/3 of basin length, can we cut down the supply? That is the idea we are talking about. And there we are talking about and can we put some kind of a solution at this point, and some kind of a devices. And I will give you just very small story behind it. When I was doing my PhD in a rural area of Australia, one of my technical officer was working as in a New South Wales agriculture department, and he invited me to his farm. His very small farm, probably 5-10 acre as compared to the Australian farms. So when we were having a coffee inside his house, there is a some noise came, some kind of a alarm came. And he said, I asked him, what is this? He said, I have put a water baby. He kind of developed a device, or a local market device is available where it is being kept at a 2/3 distance of the basin. And there, the moment water reaches to that point, an alarm came to his house, a simple alarm, and he gets the information he has to cut down the supply and move it to next basin. So those kind of simple solutions we need to come up with that. And then kind of you can create a more complex information when you have a wireless automation. You have a distance-based information is there. You have to reach water once it is reaches. So we know how much time it takes to reach this water to here, or distance-based. Either you put some kind of a device here at a 2/3 of a basin distance, and then that communicates to some information and communicates to his house, which automatically opens or shut off the gate here. First gate, if it is started at 7 a.m., he knows, and in his computer system, he can plan it that 2 hours for first basin, then 2.5 hours for second basin, and so on like that. And automatically actuator-based information is communicated to him. And that's a wireless automation is happening. And this is what happening actuator-based, and it has been applied to almost 100 farms at that time. I can say the story of almost 2006 or 2007 when I was working with them, using my information on those kind of things. So it is commercially happening. Now here in a small system allows farmer to program duration, and then again experience of distance or time he can put it, frequency based on again experience. So a lot of experience is coming, which can be cut down to more sophisticated device as we improve upon. We start with a small Maruti and then we can go up to the BMW kind of technology. So, and if BMW cost of technology can be brought down to the range of Maruti or little bit better than Maruti, then it is everyone can afford it and everyone can take it. So you can optimize up to a certain extent when to irrigate, how much to irrigate, and what is happening below the surface, and those kind of things is happening. And we get a lot of benefits out of it. Allow more efficient use of water, reduce the water uses, allow better water techniques, improve crop production, reduces salinity, reduce cost, reduce injury potential, monitor water use. Customer always have a latest automation technology, reduce labor by almost 95%. And this, I will give you the example of, we calculated the advantage in terms of a farmer when he is managing say 500 hectare area. And every time he has to come from his house to his farm by burning diesel or petrol and by bike or motorbike or car to cut off the supply or and start the supply. And he saves a lot of fuel on that. At the same time, quality of life, because he cannot, and this happens 24 hours. This is a biological system. We are not talking about during the day. So 24 hours water application is happening. And that's how the benefits have been created. Some of the photographs of that and those kind of gates are there, and which communicates the information and opens it and shut off the supply when information is being provided to that. It includes all communication. Here we are not talking of any sensor or anything, simply actuator based information. And if I show you a kind of a system, if he has that kind of home base is there at his home, and every basin he has put in an actuator based some kind of a gate which communicates with the base house, and based on that he is already planned that A area will be irrigated on Monday, B area and C area and so on like that. Sitting at his home, he is getting that kind of information and seeing this happening. At the same time, some kind of a safety mechanism is there. Suppose gate is stuck up, or gate does not open, or gate it opens but it did not close. So those kind of a triggers is coming into his mobile and getting this information that yeah, at a particular basin number so and so to 24th basin has got that kind of problem. The gate is not opened, or some wood have been stuck up, or some stone has come up, or some debris has come up and gate opened or did not close. So automatically whole cycle becomes difficult. And at the same time, he has to do manually the kind of management. Suppose rain comes in between. So whole system, he doesn't need irrigation. So whole system need to be shifted by say 3 days, 4 days, 5 days, so on like that. So those kind of actuator based flood irrigation system is being practiced in Australia and commercially. At the same time, we wanted to develop a more advanced based system. Can it be linked with where the human intervention or human knowledge or heuristics can be cut down to the minimum to enhance the efficiency. So those kind of thing has been introduced in those systems by us as a researchers. Now, in this kind of thing, savings are good, time is saved, labor is saved, cost is cut down substantially for travelings, and all other benefits are there. So what is the need for that? But still we need kind of improvement. So more of a advanced system. Why not we improved our automation by putting some kind of a sensor? Now here we are putting a sensors at different places in different basins. Then the question of research question comes, how many sensors per basin? What depth sensor should be there? We will talk about that in subsequent part of my lecture, and what the research questions are, which we are working together. So we introduced a kind of a sensor-based information system. Now this sensor provides to the combined together information, provide the controller sort of thing, and where this information is being processed, and provide the information to the gate that when to turn on or when to turn off. The ultimate decision making is gate to open or gate to close. When to open, when to close are the research questions or information that kind of need to be coupled, and then dissemination of this information using app or software or desktop based software, or in a more simple, he is walking into the supermarket and having a mobile with a app, and he at the same time monitoring the information that, yeah, my second basin is being irrigated and third basin is to be started, and so on. And based on information, and there are threshold values for that soil moisture, when to start, when to stop. So those are kind of things, and farmers are ready to accept that kind of change? That is another question. We need to come up with solutions. So what could be the expected benefits of soil moisture sensor-based information? A lot of water saving, you need monitoring, improved efficiency, a lot of time saving, and you get the information of the farm. Productivity, obviously, you are providing water as and when required. Here, human intervention is gone. We are talking of a soil moisture, which could be providing information to the farmers or users, and then providing economic benefits or environmental benefits, and a lot of savings are there. Now then we improved upon as a research team and all that, we improved a proposed system is being identified, and a integrated controller module need to be developed, which has an information module, operational module, at the same time planning module. And this could be converted into app, and then information module, information is being collected on basis of soil moisture, what kind of flow rates or the water is being provided into that, how the water is moving forward, or where the restrictions are coming. And then planning module, you need to have a crop plan. What kind of crop you are talking of, irrigation plan, and simulating the irrigation simultaneously. A lot of knowledge is going into that. It is not that as simple that simply switch on or switch off system. So being agriculture system, and then real-time soil moisture information is communicated to the control system. Flow rates have been, sometimes you are not getting a same flow rate. So accordingly, system modification is required. Then monitoring the water advance and irrigation in event control is there. So centralized irrigation operational module is there. Those kind of information is being collected and provided. And you can say the brain is this, and how the system operates. Now, the same time, how this system will work. Like initial information is being collected, a lot of initial information is being collected in terms of page geometry, flow rates, topography, what we are looking for, application depth, parameters, based on flow rate sensor, flow depth sensors, you need it, time of advance and flow, you need a soil moisture sensors, and prediction of you are coming up by a solution using inverse methodology, kind of a time of cutoff, because ultimately we are wanted to know what time to cut off the supply, what time to, here we are not talking of a soil moisture, you can add soil moisture, so automatically your whole system becomes much simple, that no need for bothering of time of cutoff. Your soil moisture sensor will provide the information to gate that when to cut off and when to start. And ultimately our decision module is opening and closing of supply gate. And we need to have a lot of field instrumentation equipment for automated irrigation. So you can have an automatic supply gate. Think about this kind of automation in our canal irrigated area, where large area is still 90% of irrigated area is canal irrigated area in our surface irrigated area, and where the automation is needed and how much efficiency we can increase upon with this kind of. So you need an automatic supply gate with the open shut off control, and with a communication system. We need a PC for it, or a mobile or laptop at your home, or a very control system. So this I am showing you probably about 10 years before research work. So you can convert this desktop to a PC or a mobile or based communication system, and then and you need a communication network. There we used a communication network of Zigbee, which is free to air, not using GSM, which is again a cost intensive. And we start with the irrigation event in a first basin based on soil moisture status. What will be the soil moisture status when this kind of information is being collected? And then waterfront reaches to a first advanced sensor. Time of advance is collected to the our software or a controller. And this information, when we want a first and second control point, water is reached, we get that kind of information, inversely calculating the irrigation parameters. Simulation model calculates the time of cutoff, and waterfront advance reaches to a supply gate shut off based on time of cutoff. So this kind of automation is possible. And here I'm not talking of sensors which can be introduced later on. This is some kind of a basic Maruti model of a irrigation automation, which could be. And see, the farmers is needing this kind of information. I gave you the example of nearby Delhi. A lot of farming happens in Haryana state and all that. Farmers get the power in the midnight. And what he does, he keeps his open starter of a pump set on. Whenever power comes, water goes into the field and he fills the water. Power goes off, he doesn't bother when in the morning automatically power is being cut off, so automatically supply. He needs a simple solution that when the water is reached to a certain point, automatically cut off, it will save his water, it will save his electricity, equipment, instrumentation. He doesn't want to come from his home to and stand in the midnight of when the winter is temperature is probably 3-4 degrees in a midnight in a Rabi season of North India. And he doesn't want that kind of thing. So he needs a simple solution, probably not very expensive, probably 5,000 to 7,000, 10,000 rupees solution with some kind of a sensor, some kind of a actuator, some kind of a controller which can turn on or turn off his motor. So those kind of system is required. Now you can put it on a same inverse modeling for estimation of parameters and those kind of things in a built-in in a system which needs a lot of knowledge, lot of simulation knowledge, lot of electronics knowledge, at the same time hydraulic knowledge, and this comes up with a, and then combined together with kind of a internet, and which is much simpler now, and come out with a solution. And we can get a monitoring as well as quantification of all the inflow, what is happening, how much outflow is happening, how much water going below the soil, how much soil water is stored, what are the losses, and ultimately the efficiency. All those kind of combined information or database is being collected or providing information into it. Now, if I show you real world application, and this kind of gates have been there, which have been automatized, and these kind of field channels, and these kind of sensors in a dairy system, soil moisture sensors, which you must be saying, this is a dairy paddock, and where the dairy cow grazing happens, and we want to put some kind of sensors, this kind of sensors connected with a big pole. The reason why big poles are required, because the reason is the cows rub their body on these kind of systems. So they damage these kind of control systems or communication system. So need to put up some kind of a big pipe with a buried below the soil, and that kind of providing the information. And this communication system, you can see the soil moisture sensors, which have been theta probes have been put in there, which provides the soil moisture sensors. And this kind of communication system linked it through the Zigbee communication, wireless, and this we get the information, and we are getting all soil moisture. You have a number of soil moisture in the field and kind of information, and providing the gate operation based on that kind of information. So you have the in a spatial mode, you have so many sensors listed on there, and you get the information based on data and what is the current state of, and even if something is non-functioning, suppose a sensor gate is creating problems, so you know that its soil moisture is going below the threshold level, and you can go yourself once in a while. Some problem is there in actuator or opening the gate or closing the gate. So the kind of thing which you can create those kind of things. So this is one of the application which have been very common. Now it has become very, very common in modern world in Australia for dairy irrigation, and this kind of information has been developed and all. Now, this kind of information, when you are talking of irrigation and all that, combining together for a dairy production system, we have the software dairy mode, dairy modeling is there, and we are combining to the SRFR with the surface irrigation software, and combining integrated way, you get the dairy production system. You have a SRFR module combining together, and in a .NET environment, and we need a lot of software experts or people who are very good in this kind of combining together the softwares and putting it information to the user that what should be the if you see that how this works in a in a flow diagram. If you talk of it, we have a climate module which will be providing the all climate information about the weather information, providing the crop water requirement or the need of water, amount of water. Then you have a grazing management module, like when we are allowing our cows to graze, this kind of a grazing, and then you have a spatial mode irrigation, you have a initiation test and surface irrigation is happening. So you see the lot of modules are working together, putting up each other, linking it to each other, and come up with a dairy production system. And a farmer, he knows that on his mobile that when he is supposed to irrigate this information, when he is allowing cows to graze, how much time will be the grazing will be allowed, what will be the crop status or the grass status, and then when he need to irrigate or put a nutrient and all this kind of thing. And they are linking it together in a all combining together and getting information on mobile, and that's kind of thing. This work we did it combining together with Melbourne University along with Dairy Production Australia, Dairy Irrigation Australia, and at the farmer's place. And this paper is being published in Computer and Electronics in Agriculture by combining together this kind of information. And local consultant was also joining together. So it's not a single person who is working together. There are a lot of synergies required from a common local production people. Private industry is also involved in that. So research industry or research people from the university side or research institution side are involved and coming up together. Our goal could be a publication of paper or something like that, but at the same time, for a farmer perspective, we are talking of some kind of a module or product where he can combine together all kind of information. Now, this is the kind of dairy mode is defined by user, different simulation by modules, model output is there, and combining together production system and dairy production system and irrigation event. So we are not talking of simple irrigation. We are combining together both dairy production system and an irrigation production system. Now let's come back to somewhat a very Indian scenario, research stage, what we are doing for that. We are trying with an automatic valve for auto irrigation system, soil moisture based irrigation controller, wireless sensor network for a greenhouse, which is slowly become common, PC based wired network of multiple sensors, microcontroller based drip irrigation, tensiometer based soil moisture sensors, variable rate applicators, remote sensing and GIS, as I told you, spatial variability mapping, solar energy application in a protected cultivation, plant-based fertilizer doses. So I will show you some of the results of the studies which we did for 5-7 years on application of precision farming for input use efficiency. And again, simple example, we started with this kind of thing with a sensor-based operating and all, and combining together information. And so first step was we wanted to use a lot of soil moisture sensors. So there are probably 5-7 type of soil moisture sensors are available. So we developed standardized those sensors. We did not develop it. Remember, we are not a hardware people. We are more of a software people. Means we are not engineers in terms of electronics and developing different soil moisture. So we picked up soil moisture sensors in a different cropping systems, be it a maize wheat or a rice wheat or a kind of crops from maize, wheat, mustard. Different soil moisture sensors were standardized, and we found that time domain refractometry is the best method of sensors among the giving the best error or the lowest error. And we come up with a kind of a application of nitrogen, chlorophyll. Again, nutrient is also being applied using different type of sensors like chlorophyll meter based or leaf color chart or different type of sensors using taking the information and applying the fertilizer based on sensor. Here, nothing, no automation is there, but the kind of, we wanted to come up with that kind of information. So we come up with kind of savings in irrigation, and ultimately we found that almost we are able to save 20% of water in a 15 to 20% of water in a wheat, mustard, and we are able to save say 20 to 30 kilograms of per hectare nitrogen, that means urea. So ultimately we are able to come up with a saving, and we are not losing any yield or the productivity. So basically lowering down the cost and coming resource saving is there. So this is what we did, a lot of work on that. And then there was another issue was there on a variable fertilizer applicator. So our team from agriculture engineering division or and I am combining some of their works, don't take it, this is only my work. So I have taken a lot of information from my other scientists also, our team members. So they come up with a variable rate fertilizer applicator. So this is a conceptual drawing is there. In a variable fertilizer, we have this a microcontroller is there, and we are linking it with kind of a link it with a ground wheel. So ground wheel rotation, how much ground wheel rotation and how much fertilizer is being dropped into at particular point is being calibrated and converted into a electronic form, and algorithms have been developed with the kind of a encoder, power source, hopper is there with a microcontroller, motor driver. And this is again a local development, our scientists working with some kind of electronics people and come up with the information. And idea is to automatic grid detection is there, how much, what will be the grid size there. We wanted to know what will be the fertilizer deficiency is there. Then application of fertilizer to manage the net deficit quantity, what will be the deficit quantity, and then combining the fuser signal and processing unit and controls. And this all information has to be put into this kind of a seed cum fertilizer drill, which is traditionally available with the farmers. And we want to come up with a device which can be put in the existing seed cum fertilizer drill, and combining together this information and come up with a lot of calibration and different hopper capacity, grid number, and then calibrations of the fertilizer applicator. What will be the simulation? We come out with a simulation that how much opening is required, we get the how much quantity of fertilizer is required, and are they matching each other or not, and then we come up with the field evaluation of fertilizer applicator. So these kind of devices we are trying to develop at a institute level, so that this kind of come up with applications which can be directly used by the farmers in a much simpler way, and come up with this kind of information. Drone is being very commonly used nowadays for be it a soil moisture mapping or a nutrient mapping, and we wanted to map the crop and trying to convert it, collect the signatures through the hyperspectral camera, linked it with a drone, and in a multispectral camera, and a lot of information is being collected on a cropped area, run the drone on that, and come up with a, we can use UAV also, you can use drone also, and with a lot of indices has been developed, we converted into modeling of a product, and map generation, indices, thematic map is there, and mapping block-wise layout design, and ultimately our aim is to link it with the fertilizer demand or a nutrient demand or a soil moisture demand, and this kind of information is being combined together, and to get the information and convert it into an application or decision making. Here I would like to have we have a big phenomics panel facility. In a controlled environment, we are growing crops, and crops irrigation and water nutrient or stress, and there are say thousands of variety of crops have been tested there, coming up with that kind of information and converted. Big data is being generated, and that lot of processing is required. Come up with a decision making, what will be the best decision for that crop improvement. So those kind of modern applications have been practiced. So this again an example of a UAV image which is being collected on different dates, and kind of information in a maize field for precision farming experiment, and this kind of information is being collected. Another application which we developed is low-cost hydroponics for cultivation of vegetables and all that production system. Here you need a very, very controlled environment, controlled application of water, nutrient, and come up with this kind of information and develop a very, very low cost, say 100,000 rupees worth of a 50 square meter production system. Here the productivity, we are talking of a 5 times, 10 times more than the open field cultivation. So this kind of information and standardizing those kind of information where you have a land shortage is there, you can develop it on your rooftop or vertical farming, and you can come up with a water and new fertilizer savings, increase in yield and water productivity, and kind of hydroponic system. And again, in an open field, we are talking of a sensor controlled fertigation and all those monitoring, irrigation and fertigation. Both is being, fertigation means application of fertilizer along with irrigation. So in a drip irrigation and all. So there you are controlling the kind of sensors or tensiometers are there. They are linked to the information system and come up with a application of fertilizer and all that. And can we improve our yield and enhance the productivity? We developed a IoT-based irrigation control system. I gave you the example. It's capable of controlling any field using actuator like water pump, solenoid valves are there using internet application, which can be seen on a mobile, or controlled field irrigation using any internet-friendly device like a smartphone, tablet, or laptop. A farmer may not be standing into his field. He is simply sitting at his home and he can see that system and start the system, turn off the system, and cost is not more than 25,000. It is a commercially Now we are trying to commercialize it, this kind of information system, which can be using real application of IoT and irrigation controlling system. Here, we are not talking of any sensor or all that, but at the same time, we are trying to come up low-cost moisture sensor, combining with the IIT Mumbai people or University of Nebraska Lincoln people in USA, and low-cost moisture sensor was trying to develop, and which can be, and buying it from Amazon, probably 50 or 100 rupees, and combining it with kind of information system and using it to the field. And very simple way you can communicate and simple use it. Another challenge in our irrigation is the digital water monitoring. Water measurement is the biggest challenge. So we are coming up with a kind of a device or new design and use it in a hydraulic flume and some kind of a electronics information system for a display and all. So this kind of device has been tested and fabricated and simple putting it in our farm. And we develop a rating curve for that digital unit and all. So this kind of small innovations are required, which can be converted and placed into our farmers' field, where they can use it for use of information. Another thing is we come up with a development of an automatic check gate. This is a traditional gate. We convert it into a simple on-off type of device, and in a both direction, up and down. And then these are some kind of a, then we convert it into a remote operated like a simple device, which can be linked to a laptop, a small application, and interface is being developed and put it into that and convert it into movement on up and down remotely. Then put it into the field, and we put it into field, and with a controlled using laptop, we get the communication and energy is being supplied using soil moisture panel. Now we further developed it into, converted it into a sensor based irrigation system. Here the soil moisture sensors are there. You can see the soil moisture sensors buried below the ground and at different depths. This kind of, we put it a sample. So our research, one of my doctoral student is working on that, and question is number of sensors per basin. Remember, when we started our discussion, we were not knowing how many sensors per basin is required, what should be the location and the depth of the sensor. Those kind of research questions need to be answered. And then this kind of communication system has been developed here with the help of our one of the startups, which I showed you some later in my slides. This kind of communication is being supplied to a gateway and controller, which goes to the cloud-based server, and with the information, and this information is being transmitted to gate, which turn on or turn off the system. And these kind of, you can see the electronics devices. This is our soil moisture sensor with a solar panel. And this is our sensors, Arduino GSM module is there, motor driver is there, voltage converter, antenna, gateway, adapter is there. And this is all put it into a very simple system. Not very expensive. Probably total money we spent is probably, if beyond the sensor, is around 5,000–7,000 rupees. This whole gate cost us around 10,000 to 15,000, which is again a research mode. And that kind of a software has been have taken it from Crop Analytics. It's a startup working together with us at IARI, and this kind of a Crop Analytics, and which can be put it on a mobile, and using mobile app for surface irrigation management. Now this gate information is there, soil moisture information is there, sensor is there, and so many devices there. A farmers or a person user can be see in a Google map, and here where his sensors are there, and he get the all information and take the decision making accordingly. What kind of information is there? Start the sensor, sense the soil moisture content, inform the microcontroller if soil moisture sensor is at a threshold level. Yes or no information is there, then activate motor driver to gate open, if it is reached a particular capacity, and then shut down that and gate close, and the whole system is being operated. And all information is put in together in a small app. We did monitor the all kind of information and run the system for many times and see the different operation. Our research questions were like that with both manual. We wanted to compare both manual control system as well as sensor-based control system. So if I say what both modules have been tested, the location for opening we have finalized 15 centimeter of depth, 50% length of the field. For closing, a different two sensors are minimum required for opening as well as closing. Overall, you are able to achieve something like 87% efficiency through automation. So those kind of development are possible, and they are very simple development, and they are not using any very hi-fi technology. Simple available technology information is there. Now, another option is Agro. This I have taken it as a publication, IoT-based Agro meteorological system, where a lot of meteorological information is temperature and humidity, soil temperature, soil moisture sensors are being placed, combining together to Arduino kit and Wi-Fi adapter. This all moving to the internet and then application server, and you get a database also developed, and you get a app also, and you have a soil moisture kit. You collect the photos and GPS coordinate where the sensor is being placed. Information is being collected at a particular point, and soil moisture, soil temperature is being collected using tools for analyzing those kind of data and come out with a report, or information is being used for. And this can be done on a farmer's level also. A new user can sign up, and you put it a register and API key and development and activate the IoT kit, and there are kind of systems can be developed, and you get a dashboard where you can get a project and you get the information. This kind of soil moisture probes are there, and you can collect it, and you get the soil information and collect the information. You get a sensor data from the agriculture field, and you have a soil mapper or geomapper activity and what is happening. So you get the all information of soil, climate information, weather information. You get a soil moisture information, and taking a decision of a irrigation start, off, and those kind of things can be taken possible. So with a spatial as well as temporal scale. Now, satellite-based irrigation water management system, which is becoming slowly common, and two companies, which is one is Smartic, which is a startup again working together with us. Another is a Revolution irrigation systems, and they are collecting satellite information for weather and combining with the crop information, come out with a information for module for turning off the system. This is more commonly used in case of a polyhouse management or a greenhouse cultivation. So all conditions, soil moisture, carbon dioxide, pH, EC, automatic drip lines, this kind of information, and combining together, combining sensor and information and putting it in a simple app. The whole idea is that, and Cropelytics is working together with us for AI, IoT, and satellite-based information. You have a pump controller, valve controllers are there. This we put it both soil moisture sensors or environmental sensors or pH or EC sensors. Different sensor products are also available in the market, and with these people, and both kind of systems are available, and both you can say spatial as well as temporal. I am repeating both same thing. And this another thing is a pest analytics. That means identifying the disease based on the weather parameters or arrival of disease, or identifying the disease using a smartphone, and the variety of crop pest, and along with entomologists and farmers, FPOs, input companies combining together information, and you get the pest information, and at a different crop stage, and some insects are coming, and you get the information, and then immediately take the example of a locust attack, which has happened probably a few years back on India also. So those kind of information, once combining together a lot of weather information and pest information system, combining with the IoTs, I have a great application of this kind of technology in agriculture. The same kind of system we have put in our farmers fair. We already have that kind of farmers fair in both soil moisture sensor linked operated drip irrigation system demonstrated to our honorable ministers and all. So those kind of things are becoming very common in our country now, and they are not very expensive also. That's the interesting part. I'm slowly touched the micro irrigation automation, like automatic irrigation system. And here, in a fruit crops, not the soil moisture is important, more of a ripening stage. So you have a cameras which are monitoring the stage of a what is the stage of crop at a ripening stage, when to irrigate, when not to irrigate accordingly. But the challenges are block to block variability is there. Within block, a lot of variability is there. So integrated weather system, soil moisture system with the cameras, image processing, and that kind of coming into a decision making for orchards. So integrated soil moisture weather systems for orchards are possible and developed and by our team. And again, linking it with the horticultural people with production system, like you simply canopy temperature is one possibility, image of the crop is possibility, image of fruit is possibility, ripening stage is possibility. So all those things are possible. Here I will small touch the machinery management, and I am being, as I gave you the example of, I am running a farm operation service unit for 250 hectare area. So we wanted to know that we have a large 50 numbers of tractors and high and machineries and all those things. And so we are working off almost 187 kilometer and large, a lot of many tractors are there. So you see in our farm, you have a combine harvester, you have a machine operating different land earth moving machinery. So we have put in some kind of devices combining together at a control system. And we are putting together that kind of information, and this information is being, and so we know on our mobile or our system that where our machinery is operating, where it is there, how much time it is using it, how much fuel it is consuming. So we have it's more like an automatic system of digital machinery management, and this combining to the Google Earth map and all. So this possible. Again, digital mapping of IARI farm, we are talking of 250 hectare for field. Digital map is there instead of a Google map. We have a real-time monitoring of machinery, water budgeting, sensor actuator network, efficient management of manpower. And this IoT is, we are working on a LoRa wireless network. Remote monitoring is possible, and we are developing an Android app. So these kind of different LoRa node is there with a power source, sensors are there with the actuator or gateway, and they are not very expensive systems now with a free from GSM and all modules. So much easier for working with us. So these are kind of functional linkage we have developed for a water IoT. This is a simple. I just wanted to show before I end my lecture that this is the kind of controllers which are available probably 30 years back or 25 years, the kind of time control where operating the pipes and valves and all that. Another thing which we worked, I just mentioned in this Krishi Rural Service Delivery Platform, we developed with the help of in a public-private partnership more with TCS, and it's an interactive system between farmers and an agri expert, and it's a mobile-based information system. Like a farmer can register into it, and we provided them, and it's a two-way communication system. Normally, our Government of India information systems are a one-way. We provide a lot of SMS or information. It's not a two-way. Here it is a two-way system. where farmer can talk to us, inform us that he is facing that kind of a pest damage or insect is coming, my crop is getting yellow, leaves are getting this kind of problem, I am getting stress. And with the weather information or temperature information and combining together all this information, and this application initially called M-Krishi, then now it is called Pusa M-Krishi. And with both, we have tested it in 2 districts, in a Mewat and a Dhar. Lot of mobiles have been given, and that kind of information is there, providing them queries and asking them here. When they ask the query, we have a facilitator sitting at a center place, which is talking to the expert of irrigation, pest, disease, and providing them solution right away. And there is no need for typing also. He can speak up, record it, and that information is being sent. So considering that the cost of mobiles or communication has come down drastically, the cost is just running a 50 rupees per month kind of subscription is required as a business model. So those are very successfully running currently also in many of our farmers supported area. Advantage and all that. Lastly, I would like to conclude. I don't know I have extended, exceeded my time of lecture or not, but trying to finish. This is my last slide. So I would like to conclude that IoT in application is a need of hour for sustainable agriculture, for enhancing input use efficiencies, or for better decision making and crop improvement, pest management, machinery management, low cost. Our target is low cost IoT linked sensor based technology for farmer, using communication technology for dissemination and as a problem solver. And lastly, I have touched some of them. I cannot say I have taken all the applications, but whatever I have been working and I have been associated with, which I try to show you some of them. There is the application area is vast, and a lot of work has been going on in our country at different institutions and institutes, both IIT, combining together. We are working together with in a water security program. Slowly, and there is one big network project has been started by our parent organization, Indian Council of Agriculture Research, on precision agriculture, both IoTs, big data analytics, AI, and all those applications. But ultimately, remember, end of the day, we need to come up with a low-cost IoT-linked sensor-based information for farmers. If it is too hi-fi, therefore, are not acceptability will not be there. But if it is a very simple mobile-based information system, he will or she will be able to take that kind of information. This completes my lecture. Thank you for giving me opportunity, and I'm happy to answer. You have any questions, and if you say, I can stop sharing my presentation.
Thank you, sir. Participants can unmute yourself and ask the queries. We have received several queries in chat box also. So we'll take one by one.
Okay.
It was very informative, sir. I think the participants, they have certain queries.
I don't know how much I bored you or excited you, but this is what I have in my bag, which I wanted to share.
Sir, can you please switch on your video, sir?
Yeah, it was, I am not able to, because it is always saying you cannot start your video because host has stopped it.
Host stopped it?
Oh, okay.
Oh, sorry.
From the very beginning, I was trying, and it is always giving me the message. I thought,
hello. I have a question. Hello.
Yeah, now the video is on. Okay, please.
Yes, sir.
Sir, good morning, sir. Can I ask a question, sir?
Please.
Sir, see, was a technology with the hydroponics and how the, say, for example, you take that maize cultivation on the soil farming and maize farming in case hydroponics. So, which is a better one in the nutrient wise, and whether we why the farmers are not trying to come forward for hydroponics. It's like aquaponics, like kind of.
Yeah, hydroponics and aquaponics or aeroponics, there are a lot of terms have been used, and we have been doing it in our country, and many work has been done, and commercially it is also working. But remember, this kind of technologies are for high value crops. If you go for a maize or low value crops, may not be remunerative for the farmers, but farmers are coming forward for high value crops, be it a cucumber, capsicum, red capsicum, or flowers, or high value products. And a lot of production, because land is becoming smaller and smaller. And even commercial cultivation, like of you have a land or you have a house, you want to cultivate on the top of your roof, and you have a production system in a 1,000 square meter, you can produce something like tons of a crop, and you can sell it, and with a very, very controlled environment and with controlled fertilizer, water, limited water, you can do all kind of wonders. And there the electronic application or IoT applications are tremendous. But farmers are taking up. I'm not, I don't agree, but some areas, take the example, one of my colleague or classmate is working as a consultant in Pune, and he has a big production system, be it in Gujarat, in Karnataka, in Maharashtra, many places, and many commercial. And in small area, he is talking of a hundreds of tons of production system, be it a vertical farming, be it in aeroponics or hydroponics, both.
Yeah, is it sir? Is it a marketability of the hydroponics product in like vegetables are in the open market? Do they because they need to sell it more than the price of the normal vegetables, like which we are farming?
Necessarily.
How does it go, sir? Because
Yeah.
Marketing
is a very, very important point here. Remember this thing, until unless you have a good market, if you are not close to your some big metro where the ready demand for this kind, you cannot bank upon the 5-star hotels and all that if you want to look for a mass marketing. Certainly you get a better prices. If take the example of cucumber, there are two type of cucumbers available in a very traditional cucumber which we are eating, and there is another English cucumber, they call it. The always price of English cucumber is almost 20 rupees per kilo extra. So those kind of things are there. Capsicum, red capsicum, yellow capsicum, which is available in the market to the tune of 100-150 rupees per kilo, which is a normal green capsicum is only 20-30 rupees a kilo. So in a mass marketing, market is very, very important. Any producer, if he is thinking about this kind of thing, he has to look for first market, where the market is available.
So do you suggest me, because I am working on do you suggest me to go for like a livestock fodder farming in hydroponics, whether it is whether you
again you have to look for the market
to invest.
Whether you have the market availability in your area where the ready market is there to take up that kind of product.
Sir, the market is there, because if the livestock is a fodder, is a lot of dairy farms are there, they're ready to take up. But
yeah,
the
certainly
is,
then go for it.
They look at that the nutrient rich, the nutrients and the chemical composition of the soil may like fodder and the hydroponics fodder, whether it is more than that, it is going to give to the livestock. There will be marginal production also increase, milk production also would increase, as research is saying that. So do you suggest me to go for because we are planning to start up an aquaponics farm, but the question is that the poor farmers like in the villages, how do we suggest them to motivate them towards starting the like hydroponics or aquaponics within the small land? There are a lot of advantages, but do you suggest
my suggestion is go with a smaller unit initially. Don't go with a bigger unit until unless you see the test marketed, and hire a good consultant who is able to give you that kind of information or technology in a reasonable priced and total production system. Then only go for it. Otherwise, failure is always there in this kind of a big ventures. And when we invest so much money in this, and you need to be a little careful. You need not to go in a big way from the very beginning. Step by step should be there. That's my suggestion.
Can we suggest to farmers who have the land and able to invest a little amount? So, like for example, small, as you said, small scale hydroponics, or it would be like 10 cents, 5 cents. It would be costing around 5 to 10 lakhs like that. Because the farmers, do they get any subsidies there in this kind of farming? They get any
I'm not aware of any subsidy, but the subsidy is there on irrigation systems and all that. Still, there is no subsidy for hydroponics and all. For irrigation and micro irrigation, a lot of subsidies are there. But for greenhouse cultivation, it is there. And from under the Prime Minister Sinchai Yojana, you have a lot of greenhouse subsidy. In North India, it is there. I'm not aware of Kerala or any other state. But I remember Karnataka is there, Maharashtra is there. You have subsidy for greenhouse cultivation and all. So there they can get a lot of subsidy and start a small venture, not more than say 1,000 square meter area. They can look for greenhouse cultivation with hydroponics. And again, I suggest them to in a 2-3 crops. Maybe part of it is a fodder, part of it could be a vegetable. So those kind of thing has to be there. So he has a production from some failure or some risk aversion is always there.
Sir, some other questions are also there in the chat box.
Okay.
I will read it for you, sir.
Okay, please.
One is which sensors or how to find early stage detection of nutrient deficiency of crops?
There are 2 ways you can do it, nutrient deficiency. There are cheap sensors are available, like green seeker or SPARD and all those things, chlorophyll meters, where you can get a soil moisture, soil nutrient status about what is the deficiency of a nutrient in a soil. Then once the crop grows, you have different type of handheld sensors are there, which can tell you what is the nutrient deficiency and when should we apply. Based on that, you are able to save a lot of nutrient and increase the efficiencies.
Okay, sir. Then Elakia has asked this question. In hydroponics, what kind of vegetables can we grow, and how can we rectify if their plants are infected?
You need to have a first what type of crops. In a crops, you need to go for high value crops. Let me tell you very, very frankly, unless you are producing high value crops, you are not going to economically viable. In high value crops, you can be cucumber, capsicum, baby cherry tomatoes, or some of the leafy vegetables or salad vegetable, lettuce or zucchini or Brussels sprouts, and those kind of crops are there. As far as the insect or pesticides are there, it is in a controlled environment. The chances of disease and all that there, you need to be in consultation with some expert from plant pathology or entomology fellow has to be there along with the production system. So the moment, because although in a controlled environment, chances of disease and pest incidents are minimal, but at the same time it happens, then you need to have a support system available with you.
Okay, thank you, sir. There are so many questions in our chat box, but I will read some of the important ones. So presently, there are many systems for smart irrigation. What are the areas to be focused if we want to do research in IoT-based smart irrigation in the present circumstances? This is asked by Shiva Shankar. And sir, one more question in the same line is Dr. Pramod Ganjevar has asked, please tell us some open issues in precision agriculture.
Okay, first smart irrigation. Let's talk of smart irrigation. I gave you the very one slide. I have simple. There are 2 types of systems available in our country, like tube based irrigation, means the farmers who are pumping water from the tube well or bore well, submersible pump sets are there, and they are irrigating. They're either producing field crops, Some of them are combining with a sprinkler irrigation or drip irrigation, otherwise flood irrigation. So for those kind of farmers, you need a kind of a simple, cheap soil moisture sensor linked, or forget about soil moisture. If you are able to do a turn off, turn on type of IoT based system that which will on his motor or off his motor whenever he wants to do it in a remotely based, and or link it with a soil moisture sensor or with a valve where he can open it in a one field, second field, third field, so on like that. Those kind of modules we need to come up with, should not be costing more than 10,000-15,000 rupees. So then only it is marketly viable. Second type of systems are surface irrigated type of systems where he has no control as such. So, but slowly in a canal irrigated area, piped irrigation is being practiced or developed by the state irrigation department. There they can kind of a valve control with kind of a information available on his mobile with a map built in, and again soil moisture sensor which will give him the information when to irrigate, when stop irrigation. So those kind of information, again a small module can be developed with kind of a smart irrigation. So in a irrigation, he can anybody can do this kind of research or come up with a product, and many people are coming with those kind of products, and challenges are there because of the sensors leaving it to the field, damaging, vandalism, all those kind of things. You need energy also with that, so some kind of a solar panel attached to it, and giving the energy also. So with these kind of challenges, once you work upon it, and you can come up with, but again, the cost should not be my emphasis is always there. It should be low cost, so less than 25,000 should be the cost upper limit. And I believe in that cost, you are able to develop this kind of information system. Then comes the precision agriculture. There are vast area where you can and use those kind of things. Just give me a moment. I'm getting a call from my director. Just give me.
Sure, sir.
Good morning, sir. ठीक है सर, मैं आपसे 15 मिनट बाद बात करूं, मैं एक लेक्चर ले रहा हूं. Is it? हाँ.
Sir, you can unmute and speak, sir. Sir, you can unmute and speak. Okay, let me see. Oh, okay. Yes, sir, you can unmute.
Yeah. Sorry about interruption. Actually, my director is calling, so I had to take up the call. So we were talking that there is a vast area for precision agriculture, and critical area. I can take the very quick. Farmers have a problem of pest management, disease management, and those kind of information, if we are, and they are closely linked with the temperature, humidity. And if it is a rise in temperature or drop in temperature or a high humidity causing a disease to attack, in particularly high value crops, take the example, vegetable production system, where if attack is any virus attack is there on any tomato crop, and it will go away like in 3 days. He lost everything. So those kind of a trigger, if you have in those kind of pest management, and where some kind of a camera or some kind of a trigger management along with entomologists or pathologists, and get information, and he is able to spray it immediately, then he is able to save his crop. Else in 3 days, he lose everything. So this is another area where our IoT application could be I have not shown a couple of slides for storage management, where the temperature and the humidity plays a critical role in a attack of insects, pest in a big storage system. or even a small storage system of vegetables and other things. Keeping the temperature and humidity at a particular level keeps them crops for at a healthy level, or a storage of grains which can be very well putting in a fumigation or applying some kind of a, insecticide or pest. So those kind of applications could be developed in a very, very efficient manner. And I think so those have a great market for our these kind of in a precision agriculture. Name few. I'm just, I hope I am able to answer his question.
Sir, one more participant want to talk with you directly, Spandana Kayeta.
Please.
Good morning, sir.
Good morning.
Yes, sir. Like for soil moisture sensor, sir, if acres of land is there, like many we need to apply. Is it necessary to put more sensor in acres of land, or only if we keep in few places? Is it worthy? Is it will give a better result or not?
You have hit a very, very critical question. This is my doctoral student PhD problem. I can say we are working on that. That's a research question, to be honest. A number of sensors, depth of sensor. So we worked on it, and we come up with a kind of a, at least minimum, if it is a say 5-acre land or 2-hectare land, at least 2 sensors are required, and a particular depth. One is for opening the starting of the irrigation, one is for closing. So both, because soil moisture trigger is a time dependent. Again, response time of our soil moisture sensors are a bit slow. And again, if you don't want a sensor of a very, very expensive cost, so your value of a whole system becomes economically unviable. When you are talking of some kind of a cheap sensor which can last for 4 to 5 years, and their response time is there. So you need at least minimum 2 sensors per 5 acre area, at least 2 hectares. So per hectare, at least 2 sensors. If smallest unit I am talking of 1 acre, minimum 2 sensors are required. I can say this is my research output. We worked on extensively on that, and we are going to publish it very soon. And some of the publications are already in the pipeline.
Sir, one more just suggestion I am asking. Like, is it go with microcontroller is better, or like microprocessor like Raspberry Pi kind of thing? If we go for research and soil moisture.
Here you are catching me in a wrong foot, because that's not my area. I believe it's some kind of a microcontroller is required, Arduino based information. So you people are a better knowledgeable or better expert in that. I go with my electronic expert or some people who are helping me in or a startup. So I don't want to put my lag into this. So maybe I may say something absurd, Roti.
Okay, thank you, sir. Thank you.
Thank you very much, sir. I think you have addressed all the queries we received. So it was very informative, and we found active participation from the participant side. They're very interested, and rich information we got. So I think many participants will contact you after that. Okay.
And,
thank you very much, sir.
I should thank Dr. Mary for giving me opportunity. It's really wonderful to talk to somebody sitting very far, and hopefully in one day I will come to your college physically to visit.
Okay, you have a lot of scope here, sir. Kasaragod is a place where acute shortage of groundwater.
Yeah.
Okay, so a lot of scope for your work. Thank you very much, sir. Happy to have you. Thank you.
Thank you, and goodbye. And have a safe. Take care. Be careful with this kind of environment you people are facing. We are far, but we have faced this kind of environment probably a couple of months back, and we suffered a lot. So thank you. All the best, and take care.
Thank you, sir. we'll have a break, 5 minutes break, or continue the session. Okay, I think we can go to the next session. Our resource person is available, so we are going to session. Hello, Mr. Gaurusha, can you hear me? Hello, Mr. Gaurusha, can you hear me? Hello, hello, hello. Hi. Can you hear me? Yeah. Okay. Mute on. You can unmute yourself, Gaurusha. Okay.
Yeah.
Okay.
Hi. Am I audible?
Hi. Yes, no, yes.
Okay. So it was mute from the admin, so I could not.